Ready for the lesson? Woo, woo. Okay. So learning objective for today is to continue to graph equations of rational functions. These are some special cases. Let's go on with this. So we have already the definition of rational function. We know that there are rational expressions that contain an equal sign. We have an equation in this sense, right? So here is our vertical asymptote, our horizontal asymptote. We have these type of asymptotes, vertical, horizontal. We're going to go ahead and soon start seeing that diagonal asymptote. We have our steps. You guys remember their steps? We already have these down. I'm just going to go ahead and repeat them very quickly. Number one, it says use long division to rewrite the rational function. That is if needed, okay? That's it when your numerator is with a higher power than your denominator in this case. We're going to go ahead and do a second step is to identify our asymptotes, whether vertical, horizontal. We're going to go ahead and see slants. Not today, but next time. We're going to go ahead and build our input or output table. You guys remember how we did that lesson? Our input output table, remember we had asymptote, the vertical asymptote. And we got one value that was on the right, one value that was on the left. And then we did our input output. Now we also have, well, once we were able to get our values, we do our graph. Okay, ready for our first example? Yes. Here we go. Example number one. Here is not a pairing function, but a transformation here. In this case, we have x to the power, 1 over x to the power of 2. Okay. So in this case, we have our beautiful function here, g of x, 1 over x to the power of 2. Now, if looking at our general form, we can go ahead and identify our horizontal asymptote and our vertical asymptote. What would be the horizontal here? Not x over 2. It would be 0. So my horizontal asymptote would be y or x? Y equals 0, right? The equation y equals 0, horizontal. So let me go ahead and graph this one really quickly. Right here. Now this time, our beautiful denominator has x to the power of 2. Now, what do we do there? We're going to go ahead and follow the same procedure where we're going to go ahead and write our denominator and make it equal to 0. In this case.
So is it y equals 0 from the x-axis?
Yes, because no matter what x value I have, y is going to always be 0. So it's the equation y equals 0. Now, my vertical asymptote, I need to make my denominator equal to 0. This time x is not by itself, it's x to the power of 2. So I'm going to go ahead and make it equal to 0. And how do I solve for x? Square root both sides, and I get x equals 0. So in this case, we're going to go ahead and have the same value. All right. Now, our job here is to identify where in these 4 quadrants that we have made here is our graphs going to be located. So this is where we create our input or output table. So here's my input output table. Look at that vertical asymptote. We're going to use one of the values on the left and one of the values on the right. So what value on the left? -1 and +1. G of x. All right. Now, if we do -1, we have -1 equals 1 over -1 squared. This gives me 1 over 1, which is beautiful 1. Let's go ahead and do the same now for g of 1. 1 over 1 squared gives me 1 over 1, and this would be 1. So let's go ahead and graph. We have -1, +1. Thank you. And +1, +1. So in which quadrants or which parts are going to be my graphs? This is the first quadrant, second quadrant, third and fourth. So it would be in the first and second. So let's go ahead and graph them. So in this case, what do you see different?
They're usually like.
They're diagonal from each other, right? This case, they're not. They're gonna be somewhere either in the consecutive quadrants that they create right there from the asymptotes, or they're gonna be next to each other. So this is when we have a power of 2 or higher power in this case. Okay, ready for the next one? No, not yet. All right, go ahead and write example number 2. We write the function and then graph. I forgot to identify a domain and range. We'll go ahead and identify on this one. So g of x equals 1 over x minus 2 squared. We're gonna follow the same steps. We're gonna go ahead and identify our asymptotes, create our input or output table, and then identify our domain and then our beautiful range in this case. Ready? All right. So what is my beautiful horizontal asymptote? Y equals 0. So plus 0. Horizontal asymptote, y equals 0. Here it is. Okay. Now this time, our vertical asymptote is still defined, or it's determined from the new denominator, goodness gracious, from our given function here. So we have x minus 2 squared. So x minus 2 squared, and we're going to make it equal to 0. So how do we do the inverse of a square? Square root. So what would happen here? We have x minus 2 equals, we can't do a square root. The square root of 0 would be 0. So therefore, we have to now add 2. This goes to 0, and we're left with x equals positive 2. So what happened to this beautiful function? What was the transformation here? We moved 2 spaces to the right. That h transformation, that h parameter, made it move from our vertical asymptote at x equals 0, and it moved it 2 spaces to the right. So let's go ahead and make our beautiful table so we can know where our values are. Here's x, here's g of x. What would be one value for x? Eli says 1 and Samantha says 3. Okay. All right. So what would be my value for x equals 1 or g of x or g of 1? What would be my value here? 1 over 1 minus 2 squared. 1 minus 2 is negative 1 squared. Positive 1. 1 over 1 is positive 1. All right, let's go ahead and do g of 3. 1 over 3 minus 2 squared. 3 minus 2 is 1. 1 squared is 1. 1 over 1 is beautiful 1. So we have 1, 1, and 3, 1. All right, not too bad, huh? Not too bad. Ready to step it up? All right, before we step it up, we're gonna have to identify that range, the domain and the range before I forget. Domain and range, domain and range. Let me go ahead and do domain in green. I'm gonna go ahead and do range in orange. So by looking at our values, domain are all our x values. Whenever we look at our x-axis, what values are present? Let's look at our negative side, so negative infinity. It goes all the way to what number? 2. So the way that we're going to go ahead and write the domain is that we're going to go ahead and come from negative infinity all the way to 2. And then if we come from positive infinity, or from the right, we go all the way all the way to positive 2. Now, I'm gonna go ahead and show you guys how to write in a different notation. This right here is interval notation. Whenever we have two separate values in domains, we're gonna go ahead and unify it with a union. So you're gonna go ahead and see this U. So U represents the union. Basically, we're gonna go ahead and unify those two values in the domain, and we're gonna sync it all together. So from negative infinity all the way to 2, with our union of 2 all the way to positive infinity. Okay, now let's go ahead and do the same with our range. Let me go ahead and come down from negative infinity. If I go from negative infinity, where do I stop? Not 2, at 0. So my range is from negative infinity all the way to 0. And then if I come from positive infinity, and where do I stop in my y-axis? At 0. So I need to come from positive infinity all the way to 0. And I have to unify my two sets. Now remember, I cannot enclose those infinities. So therefore, I have to use my parentheses. Okay. Another word for this is all real numbers. Except X. What number is not included? 2. And then for the same goes for the range. All real numbers. Except running out of space. 0. Okay. Ready for our next example. Let me go ahead and clear. Let me save and clear. Does everybody have that? Let me know if I'm going too fast. No? Okay. Let me go ahead and clear. All right, example number 3. Let's go ahead and write this one down. Or do you guys want to try this one on your own? Okay, go ahead and try this one and see what you guys get. Okay, you guys ready?
Oh, wait, should I stop graphing this?
Wait for 2 graph. Okay, just hold on. Okay, so you guys already shared with your neighbors, right?
Yes.
Okay, perfect. So let me go ahead and first graph my vertical asymptote, sorry, my horizontal asymptote. It's y equals 2, so I have it right beautiful here. All the way through. Perfect. Next one, I have my my vertical asymptote. I have x plus 3 squared equals 0. Square root both sides, and I have x plus 3 equals, which I have x equals negative 3. Okay, so right here. So which two values did you guys pick for your beautiful table? Okay, so let me go ahead and pick my colors. -4 and -2. Let's go ahead and try them out. Let's see what we get. Now, g of -4 equals -1 over -4 plus 3 squared plus 2. Okay. We have now -4 plus 3 gives me -1 squared. So this is -1 plus 2, which is
One.
positive 1. Okay, positive 1. Now let's go ahead and go g of x, g of -2, -1 over -2 plus 3 square. We get plus 2, -1 over, what is -2 plus, there you go, it's positive 1 squared is 1. -1 over 1 is -1, so therefore we have -1 plus 2 again. We get beautiful 1. So at -4, it goes to positive 1. At -2, it goes to positive 1 as well. So which quadrants?
3 and 4.
It looks like 3 and 4, but we're gonna go ahead and say, yeah, 3 and 4. In the new made quadrant from the asymptotes.
Wait, how did it?
Isn't it 1?
This is 1, this is 2, this is 3, this is 4.
So
It's in the
like
second-
new one.
And that's why I said in our new made from the asymptotes. I tried to correct myself here. Yes, you were right. Okay. All right, ready for the next one, guys. Ready to step it up this time.
Wait, but what about the domain and range?
Oh, that's right. Thank you. Let's go back.
Because I was trying to figure it out.
All right, so my domain and range. Let's see my domain. Let me go ahead and do it in green. My domain, I'm gonna go ahead and look at all my X values from the negative to the positive value. Where did it stop?
-3.
At -3. So I'm gonna go ahead and write domain. It goes from -infinity to -3. It's going to have a union. And it's going to go all the way to,
-2 to positive.
there you go, from positive infinity all the way to -3. So -3 all the way to positive infinity. Now my range is going to go from, let's see, I'm going from the negative side first. Where does it stop?
0? Oh, 2.
2. So it goes from -infinity all the way to 2, my union. And it's going to go from positive infinity, where does it stop? Beautiful, positive 2. So we go from 2 and positive infinity. All right. Another way to write this out, we can go ahead and say all real numbers, except 2, and the same goes over here. The set of all real numbers, except, let's see, -3. Okay.
Wait,
All right.
so domain is sideways and range is up and down?
Our domain is, imagine that you have a number line. All of your X values. Your ranges are going to be all of your Y values. So we have 2 sets of number lines, basically. One is just this way.
I was just confused about the domain and range.
Okay. All right, let's go ahead and do this one. G of X equals -2 over X squared plus 4X minus 12 plus 4. So this one's a little bit different, yet not complicated. Don't get scared. Don't be scared. Okay, everybody has this one down?
Yes.
I'm trying to see where I have it. Okay.
Knows 4.
All right, so let's go ahead and identify off the bat our horizontal asymptote. Horizontal asymptote is Y equals beautiful 4. Okay, so horizontal asymptote right here. Off the bat. Beautiful. Now, how do we find our beautiful vertical asymptote?
So we square it equal to 0.
Close.
Factor out.
We make our denominator equal to 0, and Alyssa was saying Power Ranger method, we need to factor it out. So yesterday I gave you guys some factoring examples, right?
Yeah.
That's why I was. We're gonna go ahead and bring factoring out. So vertical asymptote, we're gonna go ahead and grab that beautiful denominator. We're gonna go ahead and find those excluded values. So we have X squared plus 4X minus 12 equals 0. Let's go ahead and factor this out to numbers that multiply to -12 and add up to 4. 6 and -2. 4 is positive, so 6 has to be, there you go. 6, X plus 6 and X minus 2 equals 0. So from here, how many excluded values are we going to have? Those. We have X plus 6 equals 0 and X minus 2 equals 0. Subtract 6, add 2, add 2. This goes to 0. We're left with X equals.
Isn't X cannot equal?
X cannot equal, so that's going to be our beautiful X equals 2. So we're gonna have how many asymptotes this time? Dos. So let's go ahead and graph our first vertical asymptote at -6.
But so we always graph the excluded values, right?
They're graphed as an asymptote, but an asymptote means that it cannot be equal, so it's an excluded value, yes. So here is our beautiful first asymptote. This is x equals -6. And our second asymptote is at x equals 2, so we have it over here. So how many asymptotes do we have now? Dos.
I mean, 4.
Not 4, we're gonna have 3. You'll see right now. This is x equals 2. All right, so same procedure. Let's go ahead and find our input and output table. This time, how many asymptotes do we have? That are vertical, 2. So we're gonna do 1 to the left, 1 to the right on our first asymptote. And then repeat the same for our second asymptote. 1 to the left and then 1 to the right. So we have it at -7, -5, 1, and 3. Let's see what our g of x equals to. Go ahead and find those values. You can use your calculators for these guys.
Wait, so we'll plug it into the original one?
And to the original function. You can use your calculators for these. So g of -7 equals, and let me go ahead and make some space. -2 over -7 squared plus 4 times -7 minus 2 plus
Is it
4.
-12?
Sorry, minus 12. I wrote 12, but I said 2. Okay, go ahead and use your calculators for this. Let's see what you guys get.
7 times 7 is 49.
49, yes. We have -7 squared plus 4 times -7 minus 12. What do we get here in this case as a decimal value? 3.8. Now, 3.8 is correct. You might have gotten 3.777 and so on and so forth, or your fraction value or 3/7, right? So what was your value now for -5? 4.3 in this case, that is correct. You want me to solve this one out?
No.
Okay. What did you guys get for 1? 4.3. And for 3? 3.8. So let's go ahead and graph our points. For -7, it was at 3.8, which is very, very, very close, but does not pass 4. So here it is. At -5, it goes very, very close to 5, but it does not pass 5.5 or 3.5. Sorry, it does not equal to 4. Very close to 4, but it does not equal to 4. So here it is. At 1, it's the same. So we have it right here. And at 3, it's again very, very close to 4, but does not pass 4. Therefore, the way that we graph these equations or these graphs having multiple asymptotes is, since we have in this quadrant, we don't have any more asymptotes, we're going to go ahead and get very, very close. Let me go ahead and do it in round. Bless you. Very, very close to our vertical asymptote in this direction. Very, very close to the horizontal asymptote in this direction. Now, my middle section here, notice that it goes through these 2 points. So I'm going to go ahead and graph it. It goes very, very close to my horizontal asymptote and very, very close to my vertical asymptotes. And the last section over here, it goes very, very close to that horizontal asymptote and very, very close to that vertical asymptote. So we're going to go ahead and have this type of graph. Again, my asymptotes are going to define how close I get to those values, but I never equal to them. Very similarly, how close I get to them, but never equal, and how close I get to them, never. Okay, ready for your homework? Yeah. It looks like little H's.
It looks like,
It looks like
7.
Oh, that's right. Yeah.